This video instruction is for Chapter 8 in the Basic Electricity book. This is over parallel circuits. This is a parallel circuit here. Right out of the book, this illustration shows 5 light bulbs in a parallel circuit. And because of the way a parallel circuit is designed, you would have the same voltage across all of the light bulbs. Same as this circuit here, we have 90 volts, 15 ohms, 15 ohms, 15 ohms for the 3 resistors, just like we did in the series circuit that we looked at. But this time we're going to look for total amperage across the circuit, which would be total amperage in this part, total amperage in this part here. And then, of course, what you saw in the book, the total amperage is divided between the 3 resistances. So the total amperage of these 3 resistances will give us, the total of the 3 will give us the total amperage. In the book, it shows that when you're doing resistors in parallel, you need to use an inverse fraction, and I think there's an easier way to do that, and I'm going to show you that. So let's take a look at what the total resistance is for the circuit, and that's what we're going to calculate. There's a formula called product over the sum, and product over the sum works if you're doing 2 resistors in parallel. So for now, we're just going to take these 2 resistors, the second and third one here, and we're going to multiply and divide by the sum, product over the sum. And that is 225 for the product and 30 for the sum, and the total is 7.5. So that tells us that these 2 resistors, 2 15 ohm resistors, is actually a 7.5 ohm resistance. So now that we have the total resistance of these 2, and anytime you have 2 resistors of the same value in parallel, you're going to end up at half the resistance. That's just the way product over the sum works. So now we're going to cut this down to where we only actually have 2 paths for current to flow. We're combining those 2 15 ohm resistors, and now we're showing it as just one 7.5 ohm resistor. And we'll do product over the sum a second time. 15 times 7.5 is 12.5. 15 plus 7.5 is 22.5. And now we come up with a result of 5 ohms. Well, 5 ohms is the total resistance in the circuit, because when we took the 2 resistors that were here on the end, we ended up with 7.5 ohms. And now we've got the 15 and the 7.5, and that totals 5 ohms of total resistance. Now, one of the things you want to remember, anytime you have 2 resistors in parallel, the total resistance is always going to be lower than the lowest value. So you know it's going to be less than 7.5, and in this case, it's actually 5 ohms. So now if we take our 90 volts divided by 5 ohms, we know the total amperage of the circuit is 18 amps. 18 amps is what we have right here. 18 amps is what we have right here. Now, in our resistances in the 3 paths that we have for current to flow, the amperage is going to be divided. Well, of course, since we have 3 resistors of the same value, the current flow through each one is going to be the same. And really, we could have taken 90 divided by the 15 ohms and figured out that each one of these parallel paths was going to have 6 amps, and we would know that the total amperage would be 18. In one of the questions, in the chapter questions, it would ask you if you added another resistance. If we added another resistor out here, another 15 ohm resistor, a 4th one on here, would that increase or decrease the amperage? Well, it's going to draw 6 amps. It's going to make the total 24. So another resistor here would increase the amperage. If we take this one out, the amperage is going to reduce, because now we only have 2 paths, 15 ohms, 6 amps each. We only have a total resistance, a total current draw of 12 amps.